Today we're talking about populations and samples. We are going to be talking about collecting data. And when we collect data, we're going to come up with a question. Maybe we're going to use a survey to collect our data, and we're going to target certain groups of populations. Okay, so we're going to do some definitions so that you can understand the difference between a population and a sample. A sample is a subset of an entire group. It refers to a portion of the group with specific characteristics. Data collected from the sample is called a sample statistic. So, for example, vowels are a subset of the alphabet. So it's like a more targeted group of the bigger group we're discussing. Populations are when we're collecting data, the population references the entire group. Data collected from the entire population is called a population statistic. The alphabet is equivalent to the population, while consonants would be a sample within that population. So again, the population is the entire group, whereas a sample is a more specific group within that group. So we are going to look at some populations and then determine possible samples from that population. Now, these are just examples. There's many more that you could choose. So you can stop the video here and go through these on your own, or you can just work your way through these questions with me. So if I am trying to create a survey and I want to target people living in a specific neighborhood, that would be my overall population, people in a specific neighborhood. But I might not want to survey everybody in the neighborhood because that would take forever. I'm going to target just a small sample of that group. Depending on what information I'm seeking, I could sample the elderly people within that neighborhood. I could sample the kids in the neighborhood. I could sample the adults in that neighborhood. So again, the sample is just the smaller, more specific group within the population. If I was to try to create a survey to gather some data and I want to know more about a certain topic considering families with children. But again, I don't want to survey every single person, every single family with children. I might just survey families with only one child. So that's my small sample for the whole population. I might just want to focus in on that sample group. If I have a population of seniors at East High School, I could sample seniors who drive their car to East High School. I could sample seniors who ride the bus. I could sample seniors who walk. So all of those groups are samples of the bigger population. On questions 4, 5, and 6, you're given the sample and then you can come up with the population. So you're given that small picture, the small sample, the snippet of the greater group, and you can come up with the group that they're trying to discuss or trying to survey. So if I have children who play football for the YMCA, the greater population might just be people who participate in the YMCA. If my sample was students who were on the B honor roll for the first 9 weeks, then the population might be all of the students enrolled in the first 9 weeks. If my small sample was households that have cable in the Riverside apartment complex, then my bigger population would be all households in the Riverside apartment complex. So again, the population is all of the people within that would contains the sample. All right, we're going to talk about some random samples. So if I'm creating a survey, I want to collect data, I'm going to survey a population or a sample of the population. I need to come up with a way to do it. Am I going to go door to door? Am I going to make phone calls? How am I going to collect my data? And to do that, I'm going to have to come up with a random sample. Sampling randomly is the most fair way you can collect data. For a sample to be random, Everyone in that population must have an equal chance of being selected in order for that sample to be random. A survey is taken of favorite sports in 7th grade, but only girls are sampled. This would be an example of not having a random sample. Again, if I would like to know what the favorite sports are of people in 7th grade, of the students in 7th grade, but I only went and surveyed girls, that wouldn't really be fair because that's not really a good voice for the greater population of 7th grade students. So remember, for a survey to be random, everyone must have an equal chance of being selected for that survey. That's when we get to the unbiased versus biased samples. An unbiased sample is representative of that whole population. It's selected at random and it's large enough to provide accurate data. But a biased sample is not representative of that population. One or more parts of that population are favored over others. So, that example from before, if I want to know the favorite sports of all the 7th graders, but I only go and ask the girls, that would be a biased sample. My results would be skewed and not truthful of everybody in 7th grade. So we're going to go through and we're going to determine whether the sample is biased or unbiased. I am just going to write a B for biased, a U for unbiased, and then I will just talk through why. Okay. So you want to know the number of students in your math class who do their homework right after school. So you survey the first 12 students who arrive in the classroom. At first, this seems pretty fair. Like, oh, that would give me a large enough group that's representative of the whole population. But because you're favoring the students that arrive early to class, that's technically going to give you biased data. So I'm going to put a B there. We know that students arrive at all different times. Maybe they're excited to go to math class and they rush there. So maybe they're the type of student, to be stereotypical, maybe they're the type of student that rushes home and does their homework right away. So it's not really fair and it doesn't give an accurate picture of the population. Number 8, you want to estimate the number of students in your school who want a football stadium to be built. You survey the first 20 students who attend a Saturday night football game. Well, I'm assuming if people are attending the football games, then they're going to want a new football stadium to be built at their school. So that is biased. We're going to assume that their answers to this survey is going to give us skewed results, untruthful, inaccurate results to the greater population. Number 9, Mr. Williams wants to know how the residents of his town feel about a ban on texting while driving. He surveys 300 residents at random. This would be an example of an unbiased survey. He's selecting residents of the town, so it's a good representation of his population, and he's going to survey them at random. And he has 300 surveys he's sending out, so that's a large enough sample. Why don't you stop the video here, read question 10, and try to answer it on your own. Carlene wants to estimate the number of students at her school who prefer to bring a lunch from home rather than buy one at school. She surveys 12 students who are standing in the lunch line. This would be a biased sample. If she's talking about students who prefer to bring her lunch from home, but yet she goes and surveys students standing in the lunch line, we kind of already know what their answer would be. So this is a biased sample. It's not representative of the population she's trying to survey. Also, she's only surveying 12 students, so that's not really a large enough group. Last but not least, we've got a few more questions, and we're going to talk about random samples here. The senior class president would like to host an after graduation lock in. There will be games, gifts, and food. To decide if people would be willing to buy tickets, she's decided to conduct a survey. Determine if the various methods would produce a random sample. Remember, for a sample to be random, everyone in the population must have an equal chance of being selected. So, number 11, she selects every 10th student as they get off the bus one morning. This is actually not random, so I'm going to put an N for no. The reason it's not random is because you're only including students who ride the bus. What about those students that walk or ride the bike or go to carpool to get to school? So it is not inclusive of everyone having that equal chance of getting selected. She's targeting only bus riders. Number 12, she asked her choir director to allow her to survey the choir. This would be a no. She's missing out on so many other students' opinions when she only directs her survey at the choir students. Number 13, she meets with a counselor who selects every 20th student on the school roster. So this would be a yes. This is an example of a random sample. If you have a school roster, which is typically alphabetical, and you are selecting every 20th person on that roster, everyone had an equal chance of getting selected, so it's a random sample. This is a quality way to collect data. Number 14, she assigns each senior a number and randomly selects 25. So if she's only going to invite seniors to the lock-in after graduation, then this is okay to do. So this would be a yes. If only seniors are invited, she can select just seniors, randomly selecting 25 of those. Why don't you pause the video? You try number 15 and 16 on your own. When you're ready, press play, and I'll go over those answers. Number 15, she makes an announcement that people interested in the lock-in should meet her in the library after school. This is going to be a no because obviously she's only going to get interested individuals to show up. She's not going to get a truthful answer that way. And then number 16, a roster of the senior class is printed. Each student's name is put in a hat. The principal selects 25 names. Yes, this is a good quality random way to select students. Everybody has a chance to be selected. Everybody has an equal chance. All right, good job today. Hope you guys got a lot out of this.